Distance, midpoint, slope. I believe those are all on Unit 1. I know distance is. So if you check your review packet under Unit 1, some of those formulas are already be there. Distance, midpoint, slope. I'm not going to give them to you. The fourth one I thought about was this one. What's this one belong to? Sum, not one angle, the sum of all the interior angles of a polygon. And what's the n represent? Number of sides, yes. If you can come up with any formulas, those are the only 4 I had. Quadratic formula, I'm not going to put up there because you're given a reference sheet. So that's not one you have to know. All right, so if there's others that you want to come up with formula-wise, let me know. We'll put it up there. Yep. On the formula sheet, believe it or not. Okay. Anything else? If you think about it, let me know. Today, tomorrow, Friday. Properties, here we go. I got to know the properties of a parallelogram.
We have to know the other like slope stuff, like the like other versions of slope formula,
I'm not going to force you to use rise over run versus y2 minus y1 over x2 minus x1. No.
No, like how there's like other versions of slope, like it's
No. You're talking about equations of a line.
Yeah.
Okay, not slope formula.
Oh, okay.
Okay, yeah. Make sure you know slope-intercept form. Because I believe, if I remember correctly, I do ask one of the answers to be left in slope-intercept form. Yep. Parallelogram, rectangle, rhombus. And these are big, by the way. There are a good number of quadrilateral questions on there as far as you need to use a property. Isosceles trapezoid. I'm not putting kite up here because I'm not going to waste your time. Okay? Don't waste your time. You don't need to know anything about a kite here. We didn't put a kite on the midterm. Anything else you want to ask there? Huge. Know your properties. Look back at your I know it might be painful, but look back at your quadrilateral test. All right, that's the best thing you can probably do there, and obviously do the ones that are in the midterm review packet. You can write squares, but remember that's all the properties. So if you've memorized parallelogram, rectangle, rhombus, you got the square down. All right. And here you go, special vocab. Here's what I'm talking about. Remember these? Circumcenter. Others? In-center. Centroid. And there was a fourth one called the orthocenter, but I'm not writing it down. What should you know about these? Ready? Here's what you should know about them. How are they formed? How are they formed? Special fact about each of those 3. And you're ready for this one. Can I construct it? If I give you a triangle and ask for the circumcenter, can you construct it? Those, I believe, I'm pretty sure, pretty positive, those are on the YouTube channel that Miss Venezia and I put together. All right, that there's a link on Aspen. Okay. Am I going to go over these at this very second? No, but if later on today you want to ask about them, if you want to ask them about it tomorrow or Friday, feel free. Okay, I'll review anything you want. All right, but I just wanted to bring those up so you don't forget about them. Okay. I think that's about it. That's all I. Oh, and yes, there are, I think, 2, maybe 3 questions where your answers must be left in simplest radical form. All right, there are 1 or 2 questions, not multiple choice either. Actually, you have to do it. Leave your answer in simplest radical form if you need to review that with me. We all good? So that's all I have for you right here today. I just wanted to review that stuff with you. It's your show. I thought we had a very, very good discussion second period about a bunch of stuff, but you guys may go a different direction, so I'll leave it up to you. Questions, topics, yep.
I know how to draw that, but I don't know how to like dimension it correctly.
Not gonna have to worry about it. No, don't waste your time. Not gonna have to worry about it. Yep.
Can you do this with quadrilaterals?
Pick one.
Um,
Should be unit 6, I believe, towards the back of the packet. Whatever one you want to do. There's 2 types. There's statements, reasons, and then there's the coordinate geometry, which we did a lot of quadrilateral ones with. Your choice.
let's do 26 on
Page
page 74.
74.
I felt
Can we pick a different one?
all right.
Because this one, if you guys want to actually cross this one out, this one is ridiculous. All right, why you have to prove it a rectangle? You can cross that one out. Don't worry about it. 28, sure. All right, you can do that one. That's no big deal. Prove it's a parallelogram. One's congruent to 2. Got it. All right, here we go. Let's try to get this bad boy to be a parallelogram. Let me first start. One's congruent to 2. What conclusion can come out of that one? If one's congruent to 2, what comes out of that? If DC is parallel to AB. Yep. All right, so that's the first conclusion we can make, that DC is parallel to AB. The reason being, what type of angles are 1 and 2? They are congruent alternate interior angles, and that implies I have parallel lines. Yep. Okay, let's stop there. Now that I know these are parallel, what else would make this into a parallelogram? There's 2 different ways I can go right now. What else says that it would be a parallelogram? One way, Grace.
You can make DC and AB congruent.
Okay, I could make DC and AB congruent. That would be my special case. That's one way. Or, Evan? Or the other 2 opposite sides are parallel. Whatever we can do. Prove these 2 congruent, or prove the other pair of opposite sides parallel. Whatever we can do. Can we first just talk about that given? DB bisects AC. What conclusion can you make? DB bisects AC. What do you got coming back? Which two line segments are equal then? AE is congruent to EC. All right. AE is congruent to EC. Definition of a bisector. Okay, remember what we're trying to do. Prove the sides congruent or the other pair parallel. I don't know what you want to do here. I think you can maybe guess here where we're moving towards. What else do you see I could do here? Hi, Marin. Okay, how about that, guys? Say these vertical angles are congruent. Prove the triangles to say CP, CTC, the sides. Pretty good plan. I think might be our only plan. So vertical angle DEC and AEB are congruent. Vertical angles are congruent. Anybody got a method why the triangles would be congruent? Which one of the 5 am I working with? Which one of the 5 methods? Come on, let's go, let's go. Angle, side, angle. Remember, there's 5. There's 5 we got to know. Triangle AEB. Congruent. Make sure you're back in the congruent habit. The similar sign should never appear on this midterm unless it's above an equal sign. That's the only time. Let's see, if I go AEB, I got to go CED. And then CPCTC says side DC is congruent to side AB. CPCTC. And now I have a parallelogram. I just want somebody to tell me in a decent reason why. ABCD is a parallelogram. Some keywords I'm looking for. Millen, go ahead. I do need opposite in there. One pair of opposite sides, congruent and parallel, imply a parallelogram. There it is. Also be prepared to do this on a graph, a coordinate geometry one. Okay, be prepared as well. All right, there's proving a parallelogram, quadrilateral proof. What other topics, questions? Evan? A what? All of them? I can get you the centroid. We went over one of those this morning. Where's the centroid one we went over? There it is. Oh boy, I have no. It's unit 5. I know it's looks like unit 5, question 1. If anybody has the page, you can yell it out for everybody else. 49. Okay, here we go. Point Y is the centroid of FAT. Got it. PY is 8. TY is 18. FY is 4 more than AY. All right, I'll get to that in a second. All right, this goes back to my special vocab from beginning of class. What do you have to know about a centroid? Okay. A lot of voices going on. Breaks the median into a ratio of 2 to 1, meaning the distance from the vertex to the centroid is double the centroid to the side of the triangle. This distance is double this distance right here. So if we kept filling stuff out, what's the length of YI? 9. How about AY? 16. Remember, the distance from the vertex to the centroid is the bigger distance. Now, FY is 4 more than that, so that's 20. And what's gy going to be? 10. Now, is it going to be that easy? No. Here's what you can expect on the midterm. I'll tell you ty, I'm just making this up now, 6x minus 3, and I'll let you know iy is 4x minus 1. What's the length of ti? All right, so you're going to have to do something with these two other than set them equal, okay, because they're not equal to each other. And I talked yesterday, have discipline Tuesday. What do I mean by that? What do I mean by have a little discipline after you're done with the problem? If you solve for a variable, take a deep breath, look back at the beginning. Did you solve what was asked for? Because most of the time on this midterm, solving for the variable is not going to cut it. You have to plug it back in and do something with it. Have that discipline on Tuesday. All right? We good there with the centroid? All right. Ooh, in-center and circumcenter. Circumcenter, there's not much really other than what's the special fact you should know about a circumcenter. Equidistant from the, not the sides, the vertices. Vertices, yep. And the in-center is equidistant from the sides, yes. And then know how to construct them. Okay? If I'm going to give you an actual algebra problem, good bet it'll probably be a centroid question. All right? Hi, Grace.
Hi. On vocabulary to know, it says orthocenter, so we just cross that out because you said we don't.
Well, I just put all the vocab in there, but I'll tell you now, yes, orthocenter will not appear anywhere on that midterm. Maya? Point of concurrency, that's those vocabulary terms we just went over. So the circumcenter is the point of concurrency for the perpendicular bisectors. The in-center is the point of concurrency for the angle bisectors. And the centroid is the point of concurrency for the medians. Yes, medians. Yep. That's it. That's all we're going to do here. So, hey, I'm fine with that. I'm not going to force you to ask questions because if nobody has questions, the rest of the time is grinding away to the bell. But that's your call. Hi, Sarah. 75. Coordinate proof coming up. Fred? It's kind of amazing because somebody asked the exact same question second period. We did that at one second period. There it is. All right. So I'll give you guys an opportunity to get that graphed if you haven't done so already, and we will talk, how do I make this into a rectangle? All right, before we do one of the ways, let's talk. There are 3 different ways I could show it's a rectangle using slope, midpoint, and distance. First one is show it what do you know about the angles of a rectangle? Show it has all 4 right angles. Okay? If you do not want to do it that way, you are forced to prove it's a parallelogram first. All right, somebody give me what makes a parallelogram into a rectangle. It could be a parallelogram with only 1 right angle. Don't need all 4 if you show it's a parallelogram. 1 right angle, or with, anybody, diagonals of a rectangle? congruent diagonals. All right, can we make a class decision, please? Okay, let's make this easy. Who wants all 4 right angles? Who wants parallelogram with the right angle? All right, looks like we found a winner here. All right, now that comes to another question. How do you want to show it's a parallelogram? Opposite sides parallel, congruent, diagonals bisect each other. What are we doing here? Opposite sides parallel? Okay, you got it. And honestly, that's probably the best way to do it, because how are we going to show it's got a right angle after we do it a parallelogram? Slopes again. So we might as well find the slopes to begin with, right? All right, so I'll give you guys a minute to find the slopes of all 4 sides, whether you use change in y over change in x or you actually use rise over run. It's up to you. What do you guys have? Slope of FR? Should be positive 1/2. Slope of ED also should have been 1/2. How about the slope of RE? -2. And the slope of FD. All right, remember what you're doing here. You are showing me it's a parallelogram first. So what did you just learn in step 1? You're showing me it's a not a rectangle yet, parallelogram. So what did you just learn in part 1? You showed, let's see, FR and ED are parallel. And you also showed that RE and FD are parallel. Why? Slopes are equal. All right, now what do you know about the figure? Fred's a parallelogram. What's a good reason why, based on the work we did? Opposite sides are parallel. Okay, now how do I make a right angle? What do you got to know about 2 of the sides? They need to be negative. So pick 2 sides that end up being negative reciprocals. FR and RE. Okay, so we say now there's right angles, but FR and RE are FR perpendicular to RE because slopes are negative reciprocals. Whew. And then what do perpendicular lines do? So angle R is a right angle because slopes are equal. Let's yes. Whew, nope, sorry. Totally in the wrong path. Because perpendicular lines form right angles. And now what is Fred now? A rectangle, yep. Step 6, Fred's a rectangle. What's a good reason why it's a rectangle? Got to say it's a parallelogram because it is a parallelogram with 1 right angle. I got a follow-up question for you that somebody asked second period. If I wanted to continue this and say it's not a square, what's your next move? There's a part B question that says prove it's not a square. Prove 2 consecutive sides are not congruent, or diagonals are not perpendicular. That's the other way. Okay? Yes?
Can we do
Number 4 on page 50. Is this our second indirect one we're going to do? No? Oh, yeah, yep. Which one's the shortest one? All right, all right. Got it, got it. Okay, before we answer any questions, I need to know all the angle measurements in both triangles. So why don't we start there? Find the angle measurement of both triangles. Anybody finding angle BDA? BDA? What is it? 60 degrees? And how about CBD? 50? Okay. Before we show how to do this one, what theorem am I going to use here to find the shortest side? What's the theorem? In a triangle, shortest side is across from smallest angle. Yes. Okay. In a single triangle, not two triangles, a single triangle. And I just can't do this problem and say 53 is the smallest angle, it's across from BD, we're done. Okay, not when I'm dealing with two different ones. So if you remember or not, the way I want to deal with this is I'm going to take each triangle separately, and list out their sides from shortest to longest. All right, so I'm going to take each triangle separately, sort them in order from their sides from shortest to longest, and then we're going to compare them. Shortest side in triangle ABD. ABD, shortest side. AD, next side. BA followed by BD. Got it. Over here, shortest side in CBD. BD, yep. Next up would be CD, and the longest side. All right, here we go. Here we go. Well, to answer this question, the shortest segment in the entire diagram, there's only a debate between two sides right now. And those are the two shortest sides, which are AD and BD. It can only be one of those two because those are the shortest sides in both triangles. Anybody see a problem with one of them? Yep. Okay, hey, if you're going to go with these two and you're going to tell me BD, I'm going to say, hey, how many sides are still shorter than BD? 2. So it can't be BD, it's got to be AD is the shortest side. Okay, can we do that here? Yeah, we can. So if you want to do all the sides smallest to largest, you got AD. So that's out of the way. Is BD still the smallest side here? No, there's still a side smaller to it, according to our list. And what's that? BA. All right, now what's the next side? BD. And because you listed it from shortest to longest, which one's the shorter side, CD or BC? CD. So the longest side would have been BC. All right. Yep. Sure. Sign out, take a pass. Anything else, guys, we want to cover? If more questions come up, we got 2 more days here. So if more questions come up, you got review session Saturday and a review session Tuesday morning. Anything else? Okay, no problem. You guys can keep going. I appreciate it if you go right to the bell, please. I don't need people hovering around the door a couple days before midterm. Or you want to start working, it's up to you.